Hello students, today we are going to talk about the Pythagorean theorem and the converse of the Pythagorean theorem. If you will go to your table of contents and make sure that you have updated your table of contents, today we will be adding notes from section 9.2. So please make sure you keep that table of contents updated. All right, in the Pythagorean theorem, in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So if you will recall from a previous course, the two legs of a right triangle are the two sides that form the right angle and make the L. So here in this particular example, A and B are the legs. The hypotenuse is a side directly across from the right angle, so we will consider this our hypotenuse. So technically, the Pythagorean theorem is c squared equals a squared plus b squared. I like to think of this as the hypotenuse squared equals the leg squared plus the other leg squared. So if you want to call that like leg 1 and leg 2, then you can call it leg 1 and leg 2. All right, so we're going to move pretty quickly into the examples. So example number 1a, we're going to find the missing length, and we need to leave that answer in simplest radical form. So probably put those calculators away, as you should not need them for this assignment. So if we look at this picture in problem A, we look here, and here we have one of my legs, and here I have another one of my legs. So I'm going to take 5 squared plus 6 squared, and that is going to equal my hypotenuse, which is x squared. So to go ahead and work on that math, 5 squared is 25, and 6 squared is 36. And if we add 25 and 36, we get 61. And in order to undo that x squared, we're going to take the square root of both sides. Since length cannot be negative, we are going to roll with the square root of 61. I have to think about breaking down 61. Remember when we did square roots in the previous assignment, does 4, 9, 25 go into 61? I'm pretty sure 61 is prime and it cannot be broken down any further, so we're just going to leave that for today. All right, problem B. If we look at this picture, again, if we identify the legs are the two sides that form the right angle. So here I have one of my legs, and here I have another one of my legs. So this is going to be 8 squared plus x squared. The hypotenuse always goes on the side by itself. Oh, not 121 squared. I squared that in my head. Sorry about that. Is going to be 11 squared. Work on our math. Again, you should know all your perfect squares through about 12. A lot of you will know them through 20, and that is awesome. So do a little subtraction here, and x squared equals, I don't know, 7, 11 minus 6 is 57. So x equals the square root of 57. Again, I need to determine if that number can be broken down. I think 3 does go into 57, so 57 can be broken down 3 times 19, and since 3 and 19 are both prime numbers and cannot be broken down, this is a radical in simplest form. All right, moving on to the next problem. We actually, instead of using just the Pythagorean theorem is often used to solve other types of problems. So there's a lot of real-world application out there using the Pythagorean theorem, and it's very relevant on every single ACT. So for example 2, we're going to find the area of an isosceles triangle with legs 14 feet and base 12 feet. You know how I feel about this. We do not have a picture, so we are going to draw us the most beautiful isosceles triangle that we can possibly draw. And we know that the area of this triangle is what we're going to find. I know that my legs are both 14 feet long. And I also know that my base is 12 feet long. So when you don't know where to start with what you're looking for. We're looking for the area. This area, this shape is a triangle. So we have to think back and recall how to find the area of a triangle. So in my world, I just use the 1/2 base times height formula. So that means I need the length of my base. So that's good because if I look at my picture, I know my base is 12. And the problem is I do not know my height. So your height is going to be this segment right here, the altitude of the triangle. And if you recall, the altitude forms right angles with, it's perpendicular to the base, so it forms right angles. So since this triangle is isosceles, our properties let us know that each of those segments is going to be 6. So really what I'm looking for now is a height. I can't solve this problem until I have a height of the triangle. So ultimately what's now happened is I have a right triangle with h, 6, and 14. So when I look at this triangle right here, I can do the Pythagorean theorem. Again, identify your legs. So we have h squared plus 6 squared equals 14 squared. So if I do some math here, so h squared plus 36, if you take 14 times 14, you get 196. And if this math is going too fast for your brain, hit pause on your calculator and you can do it on your own. All right, so I'm going to come in, I'm going to take the square root of both sides. 160 is going to be the square root of 16 times 10. And I'm going to have to come out to the left here because I'm out of space. The square root of 16 is 4. You cannot break down 10. So that means up here, I'm going to substitute in, remember this was the value of h, so I'm going to come substitute that value right in here. All right, now I can finish the problem for area. So basically what just happened was, even though ultimately I needed area, I could not find area without the height. So I had to come out here to the side, I had to find the height, and once I found the height, I can go back and resume my fun work finding the area. Half of 12 is 6. And really, I just don't have a calculator, so I'm doing all this math in my head. So that's the easiest way for me to break it down. And 6 times 4 is 24, square root of 10. If units are given in a problem, you need to make sure that you continue the units throughout the problem. All right, beautiful. Hopefully you guys recall the Pythagorean theorem. You learned it back in 6th or 7th grade. Can't remember, but at some point you've learned this. All right, Pythagorean triples. These are just special sets of numbers that if you have them memorized, they make your life oh so much easier. They show up in many, many situations with right triangles, and they form a right triangle. So when we look at what's written here, what they have really done is they said, hey, this is a leg, this is a leg, and this is a hypotenuse. And if you recall, the hypotenuse is always the longest side of the triangle. So when we look at these problems, the hypotenuse, when we look at the Pythagorean triples, the longest side will always be the hypotenuse. Now, with these Pythagorean triples, multiples of these Pythagorean triples also form right triangles. So when we look at this, if I take this times 2, 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So 6, 8, and 10 form a Pythagorean triple, which means a triangle with sides 6, 8, and hypotenuse 10 will be a right triangle. We could do that with all these triples, so double 5 and you get 10, double 12 and you get 24, and double 13 and you get 26, which means we could have a triangle with legs 10, 24, and 26, and because that's a multiple of a Pythagorean triple, we can use that. I'm not going to double 8, 15, and 17, and 7, 24, and 25. You can double them, you can triple them, but traditionally we don't catch those as often. We'll have an alternate way to figure that out, and I will show you that in a minute. Now, we could also come along and triple my original numbers. So 6 times 3 is 18. 4 times 3, I'm sorry, 3 times 3, I just said that wrong. 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. So we could have us a right triangle with sides 9, 12, and 15. And because that's a multiple of a Pythagorean triple, it will be a right triangle. For the fun of it, we'll do one more. Double 5, double 12, and double 13, which means you could have a right triangle with sides 10, 24, and 26, and that would be a right triangle. All right, so let's use the old Pythagorean triples to solve a problem. If we are given two sides of a right triangle and we're supposed to find the length of the third side, and we know that it's an integer and it's part of a Pythagorean triple, then tell whether that part is a leg or a hypotenuse. All right, so we are given the two lengths 40 and 24. So if I'm looking at this right now, 40 would have to represent my hypotenuse, but technically if I look at my Pythagorean triples, I don't know. So I'm thinking to my head, what can I do with both of these numbers? Like, what's a common factor in both of these numbers? And I'm going to pick my greatest common factor because that will really help. So what number goes into 40 that also goes into 24? They're both even, so I know 2 works, 4 works, and actually I think 8 works. So I'm going to take and I'm going to divide both of these numbers by 8. 40 divided by 8 is 5, and 24 divided by 8 is 3. So if you go back and you look at your Pythagorean triples, you have a Pythagorean triple that has a leg of 3, a leg of 4, and a hypotenuse of 5. So 40, 20, and 24 are part of that special Pythagorean triple. So now if I want that middle side, since I divided by 3 or divided by 8 to get these two numbers, if I come in here and I multiply everything by 8, I'll go back to my original side lengths. So 3 times 8 is 24, 4 times 8 is 32, and 5 times 8 is 40. So that would be the 3 sides that they are looking for. Here we have a leg, here we have a leg, and here we have a hypotenuse, because the hypotenuse is always going to be the longest side. All right, so the converse of the Pythagorean theorem. Remember, for the converse, we just switched the hypothesis and the conclusion. So this time, they tell us that the hypotenuse c squared equals a squared plus b squared. That is stated. If that's true, then the triangle has to be a right triangle. All right, so let's look at example 4. We're going to determine if the following side lengths form a right triangle. So if you think about the square root of 86, we don't exactly know what that is. However, I do know that the square root of 81 is 9. And because 9 is bigger than 6 and 7, that tells me that the square root of 86 is going to be representing my hypotenuse. So if we substitute these numbers into the Pythagorean theorem, I have my first leg, 6 squared, plus my second leg squared equals the square root of 86 squared. If we just do the computation real fast, square root of 36, or 6 squared is 36, 7 squared is 49. If you recall, squares and square roots are inverse functions, and they undo each other, which leaves us with 86. We do some quick math, and I can really do this in my head faster than I can even type it in a calculator. So 85 is actually not equal to 86. So that tells us that this is not a right triangle. All right, so take a minute, hit pause, and I want you to do example 4b by yourself. And then when you're done, go ahead and resume by hitting play. All right, welcome back. So this 6 has to be my hypotenuse, so I'm going to take my leg squared plus my other leg squared, and the question is, does it equal my hypotenuse squared, which I squared in my head. So 16 plus 25 equals 36, and we get 41, and that actually does not equal 36. Therefore, this is not going to be a right triangle. All right, that's all the notes for this lesson. There will be an addendum to this called 9.2 Part B, which is inequalities using the Pythagorean theorem. And we will see you soon. Have a great day. Bye.